The next area we're going to talk about is smoke curtains. Now, it's common to use smoke curtains to form the reservoir in which the smoke will be collected. They can also be used to separate the main smoke reservoir and adjacent spaces which may be higher than the design smoke layer base. In these cases, the curtains will be deployed from the ceiling either to the floor or more likely to some appropriate and calculated depth below which it has been demonstrated that smoke will not descend. These devices are usually made of an appropriate fabric able to withstand the temperatures predicted for the smoky gases that they may come into contact with. The curtains are usually contained in a box fastened to the ceiling, and they deploy to the design position on receiving a signal from the CHEVS control system. Deployment is often designed to take place when smoke is detected locally by automatic smoke detectors. When deployed, the fabric is kept under tension by a weighted bottom bar, which also serves to keep the curtains straight. Automatic smoke curtains are sometimes secured at their sides in smoke-stopping side guide rails. At other times, they're designed such that when they are in the deployed position, they hang freely, being fastened to the building structure only at their top edge. They then depend on the weight of the integral bottom bar to hold them vertical. The buoyancy of the hot smoke layer exerts a pressure on the surfaces containing the layer, and this pressure acts on the curtain as if it were a sail, pushing it sideways. This is something that needs to be considered where the curtains are not secured at the sides within guide rails. If the pressure is too great, then the sideways deflection becomes significant, and the bottom edge of the curtain lifts, and the vertical depth of the curtain may not be sufficient to contain the smoke layer, causing the CHEVS to fail to achieve its design purpose. It's crucially important that all smoke curtains forming part of a CHEVS are fit for purpose. This means that whatever the intended purpose of each curtain in the CHEVS design, it must be able to fulfill that purpose in its deflected position. It's therefore sometimes necessary to calculate the expected deflection of each curtain in the design and to use these calculations to specify the properties required of the curtain. So it's necessary to calculate the level of deflection and to ensure that this is taken into account. This is covered in the post-design considerations part of this course. We now need to consider the mass entrainment into spill plumes so that we can determine the mass flow rate of smoke entering the smoke layer. The spill plume is simply the plume that spills from an opening or from under a balcony and that ascends into the smoke reservoir above. There are a number of spill plume models that designers can choose from, and each has its own limits of applicability. The height of rise of the spill plume is an important feature to establish, as the amount of air entrained into the plume will be affected by the height that the plume rises. The height of rise should be measured from the spill edge to the base of the smoke layer. But if there's a downstand within 1.5 metres of the spill edge, then the measurement should start at the bottom of that downstand and not at the spill edge. In effect, we treat the bottom of the downstand as the spill edge. If there is a downstand, but it's more than 1.5 metres from the spill edge, then the measurement should simply start at the spill edge, which is normally taken to be the underside of the balcony or the ceiling. The base of the smoke layer is the lowest height to which smoke is allowed to descend. That is the design equilibrium height of the base of the smoke layer.